Today we want to discuss from Narendra Avasthi book Atomic Structure. Okay, 11th question. Let us focus. Ionization energy for hydrogen atom in ergs, joules and electric volts respectively is. Okay, what is the means of ionization energy? Ionization energy. Ionization energy means E infinity minus E ground state. The energy required to remove an electron from the atom, from the outermost electron. How much energy is needed to remove an electron? Gaseous atom from outermost shell. Okay, that is the reason why they are written like this. And then always E infinity is 0. E infinity, electron at infinity distance, means electron out of the atom. Out of the atom, energy is E infinity is 0. Okay, if you remove an electron from an atom, the energy of electron is 0. That is known as E infinity. E infinity. That is the meaning E infinity minus E ground state. We know the formula E ground state. Let us write that formula. En, okay, energy of electron is equal to minus 2.18 into 10 to the power of minus 18 into z square by n square. Joules. And there is another formula in electric volts. En is equal to minus 13.6 z square by n square. This is in units are different. E electric volt per atom. Okay, per atom. Electric volts per atom. Okay, let us use these two formula for the calculation of here. Okay, E ground state, let us in joules, let us take this one. Minus 2.18 into 10 to the power of 18, 10 to the power of minus 18 into z square. Okay, for hydrogen atom, z is 1. Okay, z is 1 for hydrogen atom. For hydrogen atom, z is equal to 1. In ground state means n is equal to 1. Okay, let us substitute here 1 square by 1 square. Okay, then the value is minus into minus plus 2.18 into 10 to the power of 18 joules. 18 joules. Next. Okay, this may write another way also according to units. Okay, you may write 2.218 into 10 to the power of minus 2 into 10 to the power of 18. Okay, you may write like this also, joules. And then on consolidation you may get the value is 218 into 10 to the power of minus 20 joules. 20 joules. Let us convert it in ergs. Okay, we know that is 1 joule is equal to 10 to the power of 7 ergs. 10 to the power of 7 ergs. Let us substitute here. Okay, on substitution that value you can get 2.18 into 10 to the power of minus 20 into 10 to the power of 7. Then what you get is 218 into 10 to the power of minus 13. Okay, this value you may write another way also, to 1.8 into 10 to the power of 12. Okay, this is on ergs. This is correct. Next, you may write it in electric volts also. Okay, electric volts, same philosophy. Use it for electric volts. Okay, let's use it. Same philosophy. 0 minus minus 13.6 into z square by n square. Same, z is equal to 1, n1 is equal to n is equal to 1. So then 13.6 is electric volt per atom. Okay, 1 by 1 by 1 square by 1 square. This is finally you can get 13.6 electric volt per atom. Okay, you may get electric volt per atom. So this is very clear. Ionization energy, how do we write ionization energy? Like this. Okay, E infinitive minus E ground state. Okay, ground state energy, you use this formula and then calculate it. Okay, you can convert. Then, okay, what is the answer for it? Okay, let us look into the answers. Okay, option A is the correct answer. Okay, let us look into the answer. Option A is the correct answer. In ergs, in joules, in electrical volts. So these are the correct values. Next problem is for hydrogen atom, for any hydrogen like system, the ratio of velocities of 1 to 3 orbits, that is 1 is to 2 is to 3 velocities will be. Okay, this is very simply one. Okay, 12th question. Answer for 12th question. Okay, for any hydrogen like systems, for any hydrogen like systems, hydrogen like systems, okay, for any hydrogen like systems, Vn is equal to V1 into Z by N. Okay, V1 is velocity of the first Bohr orbit. Velocity of the first Bohr orbit, V1 is equal to velocity of the first Bohr orbit. Okay, Vn is equal to velocity of the first Bohr orbit. Velocity of the first Bohr orbit. Then Vn is equal to 1, V1 is equal to V1. Okay, for hydrogen atom, Z is equal to 1. Here they already mentioned for N is equal to 1. So 1 by 1. Next, N is equal to 2. Then the value V2. Substituting this value here, you can get V1 into Z value for hydrogen is 1 and N value is 2. Okay, here Z by N value, so 1 by 2. Okay, next one, N3 means V3 is equal to, by substituting this value here, you can get V1 Z is equal to 1, N is equal to 3 value 3. Okay. Next, you can get these values, then write down these values. V1 is to V2 is to V3. You can get V1 value. You can get here V1 is to V1 by 2 is to V1 by 3. Okay, on cancelling these values, you can get 1 is to 1 by 2 is to 1 by 3. So this is the answer. Okay, let us focus where is the answer here. Okay, here the answer is this one. Okay, 1 is to 1 by 2 is to 1 by 3. So answer is B. Okay. Next, the volume of nucleus is about. This is the fixed concept. Volume of nucleus is about 10 over the power of 15 times that of the atoms. Okay, atom. Okay, this is very smaller than compared to the atom. It is about 10 to the power of 15 times smaller. Okay, this is the fixed concept. Okay, volume of the nucleus is 10 to the power of minus 15 times that of the atom. Next question. Okay. Okay, next question, 14th question. The electron in an atom jumps in such a way that its kinetic energy changes from x to x by 4. The changes in potential energy will be. Okay, that is the question they ask us. Okay, energy. Okay, we have a equation. Energy is equal to kinetic energy plus potential energy. This is also equal to minus kinetic energy is equal to potential energy by 2, which is also given in the other of this book, and it is also correct. Okay, I have some proof, but after giving that proof, problem becomes more lengthy. So straight away you can remember this. These energy is equal to Ke plus Pe is equal to minus Ke is equal to Pe by 2. It is enough to do the problem. Okay. Here, okay, they mentioned electron in an atom jumps in such a way that its kinetic energy changes to x to x by 4. Okay, let us see it. X to x by 4 means you can use it. Minus kinetic energy changes from x by 4 minus x is equal to potential energy by 2. Okay, on this you can do the calculation. X minus 3x, okay, 4 x minus 4x by 4 is equal to P by 2. Okay, we can get minus 3x by 4, then P by 2. Okay, minus into minus plus. So 3x by 4 is equal to PE by 2. Then PE is equal to, what is the value of PE? Potential energy is equal to 2 times, okay, 3x by 2. 3x by 2. So answer is this one. Okay, answer is 3x by 2. Okay, this is the easy way you can do the problem by remembering these values. These values, energy is equal to kinetic energy plus potential energy is equal to minus Ke is equal to Pe by 2. This is enough to do the problems very easy way. Okay. Next question is 15th question. The potential energy or an electron in an hydrogen atom is minus 6.8 electric volts. Indicate in which excited state the electron is present. Okay, in which excited state electron is present. Okay, let us calculate. Okay, we know here energy is equal to potential energy by 2. Okay, they are already given potential energy is equal to minus 6.8 electrical volts by 2. You can get minus 3.4 electrical volts. Okay, electrical volts. So how do we get which energy state it is? Okay, indicate in which excited state the electron is present. We have to find out in which excited state the electron is present. You should find out. Okay, then you can use the formula Un is equal to minus 13.6 Z square by N square. Okay, for hydrogen atom Z is equal to 1. Okay, for N is equal to 1, it is the ground state. Then you can get the value 13.6 1 by 1 square by 1. You can get minus 13.6 electrical volts. Okay, for N is equal to 1. For N is equal to 2, 13.6 into 1 by 2 square. That is means 13.6 by 4. You can get minus 3.4 electrical volts. Minus 3.4 electrical volts. Which means the energy which is present here, which match this one. Okay, the potential energy is minus 3.4. Okay, indicate which excited state. Okay, now the potential energy of a hydrogen atom, electron in hydrogen atom is minus 6.8. Indicate in which excited state electron is present. From this calculation, you have to match this energy with the second level energy state which match this potential energy. Second energy state energy is match this potential energy. We can say ground state means N is equal to 1, N is equal to 2 is first excited state. This is known as first excited state. Okay, first excited state energy. First excited state energy. First excited state energy. Okay, this is also match the energy. We have potential energy minus 3.4 here. Okay, potential energy. This potential energy is matched with the first excited state energy. So we can say electron is present in second level, that is also known as first excited state energy. Okay, on that way you can understand it. This is known as first excited state. Second level is first excited state. Then next third level is second excited state. Okay, like that you can understand it. Okay. Next, problem number 16. What is the potential energy of electron present in n shell of beryllium 3 plus ion? Okay, let us focus the question. We know KLMN, okay, are the shells, okay, are orbits. Okay, K indicates n is equal to 1, L indicates n is equal to 2, M indicates n is equal to 3, N indicates n is equal to 4th shell. Okay, next, beryllium 3 plus. Okay, atomic number of beryllium is 4, so Z is equal to 4. Okay, they ask you the potential energy. Okay, they ask you potential energy of electron present in nth shell. Okay, nth shell. So let us write an equation. N shell En is equal to minus 13.6 Z square by N square. We know in electrical volts per atom. Okay, we know En is equal to potential energy by 2. We know from this. Okay, from here. Okay, from here we know energy En is equal to potential energy by 2. Let us use it here. Okay, then substitute all those things. 13.6, Z is equal to 4, N also 4, square it. Okay, both of them are cancelled each other. Then potential energy is equal to minus 13.6 into 2 is equal to, it means 27. Okay, minus 27. Okay, minus 27.2 electrical volts. Okay, this is very easy. Okay, in this way you can understand this problem. Next question, 17 question. Okay, 17 question. Okay, kinetic and potential energy of electron present in third Bohr orbit of hydrogen atom are respectively. Kinetic and potential energies in electric volt of electron present in third Bohr orbit of hydrogen atom. Okay, third Bohr orbit of hydrogen atom. Okay, let us focus the problem. Okay, we know n is equal to 3. We know the energy En is equal to Ke plus Pe is equal to minus Ke is equal to Pe by 2. Then we understand En is equal to minus 13.6. Okay, for hydrogen atom 1 we know from this here. We can use the equation from here. Hydrogen atom Z is equal to 1, N is equal to 3. Okay, let us substitute here 3 square. Okay, you can get minus Ke. Okay, minus get cancelled each other. Here is minus 13.6, here minus Ke. Minus are get cancelled each other. Next 13.6 by 9 is equal to Ke. Okay, on calculation you can get 1.51. Okay, 1.51 is equal to Ke. Okay, here is 1.51 potential energy. Okay, we know the relation Pe by 2, potential energy by 2 is equal to minus Ke. Let us substitute here, minus 1.51. Okay, Pe is equal to minus 1.51 into 2 is equal to minus 3.02. So you can get minus 3.02, here 1.51. You can get it. Okay, what they ask, what we delivered. Kinetic energy and potential energy in electric volts of electron present in third Bohr orbit of hydrogen atom are respectively. So for this calculation we did it by taking n is equal to 3. We know the equation here. Okay, we know the equation. Then we did some calculation by using this formula. N is equal to minus 13.6 z square by n square. And this you can get, and then you get this one. So answer is B. Next. Okay, next problem is, okay. Oh, next problem, 18th problem. Okay, next problem, 18th. Okay. 18th problem is like this. The distance between fourth and third Bohr orbit, okay, orbits of helium plus ion is, okay. Let us write down the equations for it. Rn, useful equations. Rn is equal to 0.52 angstrom into n square by z. N square by z. For helium atom, they mentioned helium plus 2, helium plus. For helium, Z is equal to 2. We know atomic number is 2, so Z is equal to 2. So they mentioned third and fourth, the distance between fourth and third Bohr orbits. Okay, let us calculate. R3 is equal to 0.52 angstrom units. Okay, for 3, okay, 3 by 3 square. Okay, 3 square by 2. Okay, means you can get it 0.52 angstrom units. Okay, 9 by 2. Then what about R4? R4 is equal to 0.52 angstrom units into here R4 4 square by 2. Okay, you can get 0.52 angstrom units into 16 by 2. Okay, let us subtract one from the another. Okay, R4 minus R3 is equal to, okay, you can get 0.52 into 16 by 2 minus 0.52 into 9 by 2. Okay, 9 by 2. Okay, you can get 0.52 by 2, 16 minus 9, you can get 0.52 into 7 by 2. On that calculation you can get 1.82 angstrom units. Okay, angstrom units on conversion to 1 angstrom is equal to 10 power of minus 10 meters. Let us substitute 1.82 into 10 power of minus 10 meters. So this is the answer, you can get it. So let us see the answers. 1.82. Okay, 1.82 is very nearer to the option C. Okay, very much closer to the option C. Yeah. Okay, next problem is 19th problem. Let us focus 19th problem. Okay, here the question is, what atomic number of an element X would have to become so that the fourth orbit around X would fit inside the first Bohr orbit of the hydrogen atom. Okay, they are taking an element X. They don't know atomic number of that X, and fourth orbit of that X is equal to the first Bohr orbit of hydrogen atom. So then you can easily find out the atomic number of the X. So how do we deal this problem? Okay, let us take any equation. Rn is equal to 52.9 n square by Z. This is in picometers, picometers. Okay, this if n is equal to 4, okay, they are already given n is equal to 4. If Z is equal to, okay, if Z is equal to what? If Z is equal to 4, if Z is equal to 4, then you can get 52.9. Okay, because Z is equal to 16, then substitute both of them here. Okay, by 16, 4 square, okay, 4 square is equal to 16, then you can get 52.9 straight away picometers. Okay, 52.9 picometers for R4 is, this one is known as first Bohr orbit. This is known as first Bohr orbit. Okay, this is known as the fit into the first Bohr orbit. This value is known as first Bohr orbit. First Bohr orbit. Value. So what is the value of Z? Then this value R4 is equal to first Bohr orbit. They ask like that. Okay, Z value, if Z value is equal to 16, then this R4 value is equal to the first Bohr orbit. Okay, that is the reason we have proved it. The atomic number of element A would have becomes so that fourth orbit around X would fit inside the first Bohr orbit of hydrogen atom. Okay, on which Z value R4 is equal to first Bohr orbit. They ask like that. So we can prove that this is the value. Okay, first Bohr orbit value, R4 value are equal. When if those are equal, if Z is equal to 16, if Z is equal to 16, then only it is possible. Okay, if you are taking Z is equal to 16, then n square by Z, they are cancelled each other, then you can get 52.9 pm. Okay, 52.9 pm value is known as first Bohr orbit. First Bohr orbit. How can we say first Bohr orbit is 52.9? Okay, R1. Then you can calculate R1 for this one. For hydrogen atom, Z is equal to 1. Then 52.9. Okay, then 1 first Bohr orbit by Z is equal to 1. So you can get 52.9. Okay, then you can get 52.9 picometers. So that is the reason why this is known as first Bohr orbit value. This is known as first Bohr orbit radius. So when will this first Bohr orbit is equal to that fourth level element? Okay, fourth level element. Then Z is equal to 16. Then both of them are equal. Then we can get the answer. Then next question is 20. Okay, this is very easy. The ratio of velocity of electron in third and fifth orbit of lithium 2 plus would be, okay, simply take the value velocity equation v1 z by n for lithium 2 plus, okay, z is equal to 3. Let us substitute here these values. Therefore they ask you third and fifth. Okay, n is equal to 3. Let us substitute here v3, v1 is fixed, z is equal to 3, n is equal to 3. Then we get v1 only. What about n is equal to 5? N is equal to 5. Then substitute here v5 is equal to v1. Okay, z value is 3, n value is 5. You can get 3v1 by 5. What is the ratio? v3 is to v5 is equal to v1 is to 3v1 by 5. Okay, these two v1 are get cancelled. Then we can get 5 is to 3. So the value is 5 is to 3. Simply you can calculate like this. So this is the today class. Okay, we will meet again next 21 to 30. Okay, let us stop here.